All right, I've had some people asking me about implicit differentiation and about related rates. I'm going to try to knock them both out in this video. Keep in mind that both these concepts are just the chain rule. And the chain rule states that if you have a function inside of another function and you do its derivative, you multiply by the derivative of the inside function after you do the derivative of the outside function. So let's look at an example. Let's say I had 2x squared minus 5e to the x, all to the third power. If this is my function, I have an inside function here. We'll call that g of x. And then I have an outside function, which is something to the third power, and we can call that f of x. When you take the derivative of this, you do outside function with the inside the same. So my outside function is something cubed, so I make that 3 times something squared. Then I multiply by the derivative of the inside function, which is 4x minus 5e to the x, and I squeeze parentheses around it. That's the derivative. So to write that in our notation, this is f prime of the original inside, g of x, oops, not the same blue, doesn't matter, times g prime of x. Okay. So let's look at an implicit differentiation question. So we are given that x squared is x plus y over x minus y. And we are going to try to prove that the derivative is x minus y squared plus y over x. When I see x minus y squared, and I notice that x minus y is the denominator, that means I'm thinking about doing the quotient rule. So let's do implicit differentiation. Let's remember the chain rule, and that means that anytime we see the letter y, we remember that the letter y is really an inside function. So when we do the derivative, we do outside derivative multiplied by inside derivative. Derivative of x squared is 2x, and then here I do the quotient rule. Derivative of the top, derivative of x is 1, derivative of y is just dy dx, times original denominator x minus y, minus original top x plus y, times derivative of bottom 1 minus dy dx, all over denominator squared. If we multiply both sides by the denominator, we get 2x times x minus y squared, remembering my goal there. If I distribute out the top, I get x minus y plus x times dy over dx minus y times dy dx. And then I distribute this out, being careful with my negatives. Minus x minus y plus x dy dx plus y dy dx. Let's see if anything cancels out. It looks like I've got a minus y dy dx and a plus y dy dx. That's great. It looks like I've got an x and a minus x. That's great. And it looks like whatever is left over is doubled. So I have 2x, x minus y squared. I have negative 2y on the other side of the equals. And I have 2x dy dx. Getting dy dx by itself means adding 2y to both sides. And then dividing both sides by 2x. And then you can see that we have the result. That's an example of a implicit differentiation problem. Okay? An example of a related rates problem would be where one thing is changing and you are supposed to figure out how quickly another thing is changing. So I'm going to look for, I'll give you guys a classic example here. So let's say that we have a equilateral triangle where each side length is x, and we want to know how fast is the area changing if we know that the side lengths are getting, say, 1 inch per second bigger. Okay? And we need one more piece of information, which is that we care about this when the x is, let's say, 3 inches. So let's start by writing down what the area is. The area of this shape is going to be 1/2, and we can use our formula of A times B times sine of the angle in between them, sine of 60 degrees, which if we simplify that, that's square root of 3 over 2, sine of 60 degrees is. So you have square root of 3 over 4 x squared. When I do the derivative of area with respect to time, I get dA dt. When I do the derivative of this side, I multiply the 2 in front. So I have square root of 3 over 2 times x times dx dt. Now I can just substitute in 1 for dx dt, 3 for inches, and I get that the rate of change of the area is square root of 3 over 2 times 3 times 1, which is just 3 root 3 over 2. So that was just a real quick overview of implicit differentiation and related rates. The key idea is that you are always taking the derivative using your regular derivative rules, and then if the letter y is a function of x, you multiply by dy dx because that's the inside derivative, that's the chain rule. If you're doing related rates, then you're thinking of every letter as a function of time. And so when you take the derivative of x, you multiply by dx dt. If you take the derivative of a, you multiply by dA dt. If you take the derivative of q, you multiply by dq dt. Related rates and implicit differentiation are the same idea, and that core idea is just the chain rule. Please let me know if you got any questions. Happy to help.